Hi, I'm Sean Gannon, and this is minutemath, and today we're learning about properties of exponents. So, if I was given this problem.
Minute math. When you need help, you use minute math.
We need to simplify 2m squared times 2m to the third power. First thing I want to do here is I look at the 2's. Okay, they're both the numbers out front of each of the variables, and so we can multiply them together. All right, we're kind of combining our like terms. So we're going to combine these two 2's together. 2 times 2 is 4. Okay, well now we have the m's, right? So we got the 2's done, we have the m's. We have m squared times m to the third. If we remember our rules of exponents, if it's being multiplied with the same base, we add the exponents. So in this case, 2 plus 3 is 5. So we have m to the fifth power, and that is our final answer, 4m to the fifth power. We want to simplify m to the fourth power times 2m to the negative third power. Okay, now this becomes a little tricky. What's in front of this m to the fourth power? That is a 1. Okay, the coefficient there is 1. So we can put that in if we want. That kind of helps us out here. And now we need to multiply our coefficients. 1 times 2 is 2. So that just comes up front, and we're done with the coefficients. Now we have the variables. M to the fourth times m to the negative third power. When we have the same base and we're being multiplied, we have to add the exponents. So 4 plus a negative 3 is a positive 1. So we have m to the positive 1 power right there, but we don't really need to write the 1 power, right? Just like we didn't write the 1 as a coefficient. And so my final answer here is just 2m. We need to simplify 4r to the negative third power times 2r squared. Okay? First thing I'm looking at is the coefficients, 4 and 2. We need to multiply them to make our new coefficient and combine it. So 4 times 2 is 8. Now we have these variables of r to the negative third power and r squared. When we multiply them that have the same base, we have to add the exponents. So with that, negative 3 plus 2 is a negative 1. But we're told that we can't have any positive exponents. So we have a negative exponent here, and r is essentially in the numerator, right? This is really 8r to the negative 1 over 1. We can rewrite this to be 8 divided by r to the positive 1 power right here, which is just 8 over r. We don't need to write that 1 exponent. And now we're done. Our final answer is just 8 over r. We need to simplify 4n to the fourth power times 2n to the negative third power. Again, our coefficients here are 4 and 2. We need to multiply them together. 4 times 2 is 8. Now we have our variables, n to the fourth times n to the negative third power. When we have the same bases here, or when there are the same bases, we take the exponents, when multiplication, and we add them. So 4 plus a negative 3 is a positive 1. Do we need to write the positive 1? No, we shouldn't really do that. Okay, if it's a 1 there, an exponent, we can just leave it blank and just leave that 1n. That's right there. So our final answer here is fairly simple, 8n. We need to simplify 2k to the fourth power times 4k. First thing I'm looking at are my coefficients, 2 and 4. Multiply them together first, and 2 times 4 is 8. We now have our variables, k to the fourth power times k to the, what's there? First power. Okay? So when we have the same base, when they're being multiplied, we add the exponents. So k to the fourth times k to the first is k to the 4 plus 1, which is 5. So we have k to the fifth power here, bringing together our final answer, 8k to the fifth power. We need to simplify 2x to the third power, y to the negative third power, times 2x to the negative 1 power, y to the positive third power. First thing I'm looking at are the coefficients here. 2 and 2, multiply them together, we get 4. So we have 4 right there. Now again, we need to multiply our like terms. Let's deal with the x's first. X to the third power times x to the negative 1. Again, same base, add the exponents here. So we have x to the 3 plus a negative 1, which is a positive 2. Last one here, we have y's. Y to the negative third times y to the positive third. Again, same base, add the exponents. That's y to a negative 3 plus 3, which is y to the 0 power. But we're not done. We never really write y to the 0 power or any variable to the 0 power. Any number to the 0 power is just 1, so it's being multiplied really here by 1. So if I'm writing my final answer, it's just 4x squared, and there we have it. Our final answer, 4x squared. We need to simplify 2y squared times 3x. First thing I need to do is multiply my coefficients. We have 2 and 3. Together, they are multiplied to be a 6. 2 times 3 is 6. Now we have the y's. Well, there's no other y here, so I can't multiply it with anything else, so I just need to bring down the y squared. And then now we have the x to bring down. There's no other x over there to combine a like term, so we just bring down the x, and this one's actually fairly simple if we know our rules. Our final answer here is just 6y squared x. We need to simplify 4v to the third power times vu squared. Well, one thing we're noticing here, we have a coefficient of 4 here, and in front of this v is a coefficient of 1. 1 times 4, multiply them together, and we get just 4. So now let's deal with the v's. V to the third power times v to the first power. Remember, that's imaginary right there, or we don't really write it, but there's a first power there. We add the exponents. So we have v to the 3 plus 1, which is 4. Lastly, we have the u squared right here on the right. There's no other u squared on the left. So we just bring down the u squared, and we're done. Our final answer here is 4v to the fourth power times u squared. We need to simplify 4a to the third power times b to the second power times 3a to the negative 4, b to the negative third power. First thing I want to do is look at my coefficients and multiply them. 4 times 3 is 12. Let's bring that down. Now we have our variables. We have a to the third times its like term, a to the negative fourth power. We multiply with the same base. Our rules state that we have to add the exponents. So we have a to the 3 plus a negative 4, which is a negative 1. Now let's deal with the b's. B squared times b to the negative third power. Well, again, same rule applies. Their base b, we add the exponents. 2 plus a negative 3 is a negative 1. If you remember from before, we cannot have a negative exponent, so we have to rewrite this. This whole thing is kind of like over a fraction, and so we can bring that negative 1 in the numerator to a positive 1 in the denominator when it's an exponent. So we have 12 left in the numerator, bring both these down. We have a to a positive 1 power, which we don't have to write, remember. And then b comes down, again, positive 1 power, but again, don't have to write it. So our final answer here is just 12 over ab. We need to simplify x squared y to the negative fourth power times x to the third y squared. Our first step usually is multiplying our coefficients here. Coefficient of 1, coefficient of 1. 1 times 1 is 1. Don't need to write that. So let's deal with the variable x. Same base, both are x's. So we multiply them, we add the exponent. So we have x to the 2 plus 3 here, which is 5. Now we have the y values. We have y to the negative fourth times y squared. Again, same rule applies. We add the exponents. Negative 4 plus 2 is a negative 2 right here. So where do we go from here? Well, one thing we know is that we cannot have a negative exponent. This here is really like a fraction. Y to the negative 2 in the numerator is the same as y to the positive 2 power in the denominator, so we can write this like so. X to the fifth over y squared, positive 2, And there we have our final answer, x to the fifth over y squared. We need to simplify x squared all to the 0 power. There's a few ways to think about this problem here. Our rules state when we have something, an exponent here, raised to another exponent, we need to multiply the exponents. So I'm going to show one way here to do that. We have x to the 2 now times 0 power, which is, well, 2 times 0 is 0, so we have x to the 0 power, which is 1, right? Anything raised to the 0 power is 1. We also could have noticed this from the beginning. This whole item, whatever x squared is, we're raising that to the 0 power. And we should know that anything to the 0 power is 1. So our final answer here, no matter which way you look at it, is just 1. We need to simplify 2x squared all to the negative 4th power. This one's a little tricky. We have a negative 4th power. That needs to be applied to everything inside. So we can kind of break it down as such. 2 to the negative 4 power times x squared to the negative 4 power. As time goes on, you won't have to necessarily show that step. You'll be able to break it down. But we can show it here. 2 to the negative 4 power, this one's tricky. It's the same thing as 1 over 2 to the positive 4th power, if you can see that there. Remember that fraction, or 2 to the negative 4th power, is the same as 1 over 2 to the positive 4th power. Same thing here with this side. We have 1 over, in reality, x squared to the positive 4th power, if that's in the denominator. Okay. Now from here, we have one big fraction. 2 to the 4th power is 16. If you remember, 2 times 2 is 4, times 2 is 8, times 2 is 16. Here, we multiply the exponents. Exponent raised to another exponent. 2 times 4 is 8. So we have x to the 8th power. And there we have our answer. 1 over 16, x to the 8th power. We need to simplify 4r to the 0 power, all to the 4th power. Well, one thing I need to do with this 4th power exponent is apply it to both parts here. So in doing so, we have 4 now to the 4th power times r to the 0 power to the 4th power. Follow our order of operations here. 4 to the 4th power is 256 times r to the 0 power is just 1. All of that to the 4th power. Well, now this becomes fairly easy. 1 to the 4th power is just 1. 1 times 256, 256. So our final answer here is just a 256. 4a to the 3rd power, all to the 2nd power. Well, what do I do first here? Well, I want to take this squared here and apply it to the 4 and a to the 3rd power. So 4 squared, now I'm going to kind of jump this step. 4 squared, apply that here, right? 4 squared is 16, okay? Now we have a to the 3rd power all squared, okay? Well, a to the 3rd power all squared, we multiply the exponents here. 3 times 2 is a 6, so we have a to the 6th power, and now we're done. Our final answer here is 16a to the 6th power. 3k to the 4th power, all to the 4th power. Well, let's apply this 4th power to both parts inside the parentheses. 3 to the 4th power is 81. And then k to the 4th power, all to the 4th power. Remember our two parts here. We multiply the exponents. So 4 times 4, 16. We have k to the 16th power, and now we're pretty much done. Our final answer here is just 81k to the 16th power. 4xy to the negative 1 power. Well, the negative 1 power I need to apply to every part here. And there's a few ways I can go about this. I can go to each part individually right now from the beginning, or I can rewrite this whole thing and recognize that this whole part in here to the negative 1 power is the same thing as 1 over that whole inside to the positive 1 power. And then from there, anything raised to the 1st power is itself. So we can simplify this again. and not show the exponent, and we have 1 over xy, and there we have our final answer. Just 1 over 4xy. 2b to the 4th power, all to the negative 1 power. So this one, again, fairly simple. We see this whole thing inside the parentheses, and it needs to be raised to the negative 1 power. So what we can do is write this as if it's raised to the positive 1 power by flipping it. We take 1 over 2b to the 4th power to the positive 1 power from our rules with exponents. And then now we don't really need to write anything to the positive 1 power. So we can rewrite this without the parentheses. And we have 1 over 2b to the 4th power. And that's it. That is our final answer. 1 over 2b to the 4th power. X squared times y to the negative 1 power, all to the 2nd power. We want to distribute this squared to both parts inside the parentheses. So x squared squared, we multiply the exponents, and 2 times 2 is 4. So we have x to the 4th power here. Do the same thing with the y. Y to the negative 1 power, all squared, is y to the negative 1 times 2. And negative 1 times 2 is a negative 2. Y to the negative 2 power. But we cannot write our exponents to be negative. So what do? Well, we know y to the negative 2 power is the same thing as 1 over y squared. So we keep the x to the 4th in the numerator, and in the denominator, let's bring down the y. It is now to a positive power, and there's our answer. X to the 4th over y squared. 2x to the 4th power, y to the negative 3rd power, all of that to the negative 1st power. So what I'm going to do here is I'm going to distribute this negative 1 power to all 3 parts. Negative 1 power times to the set 2 up here is 2 to the negative 1 power, which we know to be actually 2 to the negative 1 is, well, 1 over 2, right? So we have 1 over 2 here, times x to the 4th times, or to the negative 1 power, again, same thing, multiply the exponents. We have a negative 4. X to the negative 4 right here is the same thing as 1 over x to the positive 4th power. Do the same thing with y's. Y to the negative 3rd, all to the negative 1 power. Multiply the exponents. Negative 3 times negative 1 is a positive 3. So we have y to the positive 3 power here. We now can combine this to be one big fraction. Y to the 3rd stays in the numerator, and the denominators are 2x to the 4th, and that's it. We have our final answer, y to the 3rd over 2x to the 4th power. 3m all to the negative 2 power. Well, first thing I want to do here is this negative 2 power we know is the same thing as this as a fraction, the 3m to the denominator, and the positive 2 power. So we can rewrite this as 1 over 3m to the positive 2 power, and then we need to continue. Well, distribute the 2 to both parts, or the squared, right? 3 squared is 9, and m squared, right, is just m squared. And so our answer here is fairly simple. It's 1 over 9m squared. R squared over 2r to the 3rd power. This one's a little tricky. We have fractions here. We know r to the 2nd power divided by r to the 3rd power. When we see that, we subtract the exponents. So we take 2 minus 3, and we have a negative 1, so we should have r in the denominator. You also can think of it as such. Cancel that out. 2 cancels out to be 1 down here, and that's it. We're left with 1 in the numerator, and we have 2 to the r to the 1st power, the denominator, but we don't need to write the 1st power. So we have 1 over 2r as our final answer. X to the negative 1 over 4x to the 4th power. Well, this one starts off tricky. We have a negative exponent from the beginning. What that does, well, we can think of it like this. We need to bring it to the denominator, but our rules of division really state we need to subtract the exponents. Negative 1 minus 4 is a negative 5. So where is that going to go? Negative in the denominator. Okay? So let's go We know it's going to be the fifth power in the denominator, but let's find a way to kind of get it down there without necessarily doing that. We can bring the negative 1 down, so we have 1 over 4x to the fourth power times x to the positive 1 power, if you want to see it this way. 1 over 4x to the fourth power times x to the first power. We add the exponents here, and that's easy. 1 over 4x to the 4 plus 1, which is 5. And that is our final answer, 1 over 4x to the fifth power. 3n to the fourth power over 3n to the third power. Well, this one is actually fairly simple. 3 divided by 3, they cancel, it's just a 1. We have our exponents, n to the fourth divided by n to the third. 3 n's cancel out, we're left with 1 n in the numerator, and that's it. We're left with just n to the first power, which we don't need to write to the first power, and so it's just the lonely n as a final answer. M to the fourth power over 2m to the fourth power. Well, notice we see something that's the same in the numerator and denominator, and that is m to the fourth power. Well, with the same thing with division, they just cancel each other out, and what are we left with? Well, don't forget a 1 needs to be in the numerator, but we just have that 2 left over. And so our final answer here is just a very simple 1/2. 3m to the negative fourth power over m to the third power. This one's tricky. First thing I like to do, let's bring that m to the negative fourth to the denominator. So in doing so, 3 is left in the numerator. We have m to the third power already in the denominator, but m to the negative fourth power is the same thing as in the numerator as m to the positive fourth power in the denominator. Same base, that means we add the exponents here, and so we have 3 over m to the 3 plus 4, which is 7. So we have 3 over m to the seventh power as our final answer. 2x to the fourth, y negative fourth power, z to the negative third power, all over 3x squared, y to the negative third power, z to the fourth power. We first look at our coefficients, 2 and 3. Nothing to simplify there, so I'm just going to leave it like this, 2/3. Let's keep going. X to the fourth divided by x squared, okay? Well, we subtract the exponents, 4 minus 2 is just 2, and so we have an x squared here. Now the y's, this is the tricky part. Y to the negative fourth divided by y to the negative third. Negative 4 minus a negative third, we subtract them, is like adding a positive third, 3, right? So negative 4 plus 3 is a negative 1. That means the y is going to be in the denominator, negative 1 right there. Now let's deal with the z's. Z to the negative third divided by z to the fourth power. So we have negative third minus 4. That's for the z's. Negative 3 minus 4 is negative 7. That means we have it in the denominator. Oops, this y is a positive because it's in the denominator. So we have z to the positive 7th in the denominator here. It'd be a negative 7th in the numerator. So let's rewrite this now without the 1 there. 2x squared over 3y z to the 7th power. And after all that, we have our final answer, 2x squared over 3yz to the 7th power. 4x to the 0 power, y to the negative 2 power, z to the third power. All that's over 4x, and we gotta simplify. So let's look at the coefficients. 4 and 4, they cancel out. We have nothing there. The next part is going to be tricky. X to the 0 power. Well, x to the 0 power is 1, so that's just really nothing. We don't really need that, right? Multiplied by 1 doesn't do anything. The denominator still has the x. There's no other x's up here. But the numerator, we have y to the negative 2 power. Y to the negative 2 in the numerator is like y to the positive 2 in the denominator, y squared. Now the z has to come down. Z just stays there. There's nothing to simplify with. So we have z to the third power here, and that's it. Our final answer here, we brought everything down, is z to the third power over xy squared. 2h to the third power, j to the negative third power, k to the fourth power, all over 3jk. JK. I don't know if anyone still does that. So, let's look at our coefficients. 2/3. Well, 2 divided by 3, 2/3. Can't simplify that anymore. All right, let's keep going. H to the third. Anything in the denominator to simplify with? Nothing really cancels out. We keep h to the third in the numerator. All right, got that done. Now the j's are next. What are we going to do with these bad boys? We got j to the negative third over j in the denominator. How do we simplify that? Well, negative 3, and this is the first power. We subtract that, right? Let's look at the j's. Remember, with division, we subtract the exponents. Negative 3 minus the first power. That's right there for the j. And that comes out to be a negative 4, which means j has a positive 4 exponent in the denominator. So we have j to the positive 4 exponent, but it's in the denominator. If we had it in the numerator, it'd be a negative exponent, but gotta have it positive. Lastly, k to the fourth over k. That's like k to the first power, right? We subtract the exponents. 4 minus 1 is 3. So we have k to the third power in the numerator, but now we're done. Nothing else that we can combine. So our final answer is 2h to the third, k to the third, over 3j to the fourth power. 4m to the fourth power, n to the third power, p to the third power, all over 3n squared, n squared, p to the fourth power. So what do we do here? Look at the coefficients first. 4 divided by 3, nothing to simplify, keep it as such. 4 over 3. Moving along. M to the fourth, remember combine like terms, divided by m squared. Subtract the exponents. 4 minus 2 is a positive 2, keeps it in the numerator, m squared there. Let's look at the n's. N to the third divided by n squared. 3 minus 2 is 1. Positive 1 here, so we have n to the positive 1 power. Again, don't need to write that exponent. Keep it just as an n. Last one's tricky. P to the third power over p to the fourth power. Subtract the exponents. 3 minus 4 is a negative 1, meaning it's a positive in the denominator. P to the positive 1 power. Don't need to write that there. And there we have our answer. All done. Remember, no positive exponents. 4m squared n over 3p, and that is our final answer. So, 3x to the third, y to the negative 1, z to the negative 1 power, all over x to the negative 4, y to the 0, and z to the 0. I always first look at my coefficients. We have a 3 here and a 1 in front of that x to the negative 4th power. Well, the 3 really can't have anything done to it, really, so we just leave it as a 3. Okay? So now we'll deal with the x's. Look at the exponents. X to the third power divided by x to the negative 4. Subtract the exponents. 3 minus, let's put it here so you can see it. 3 minus a negative 4 is like adding a positive 4. That's 7. So positive 7 stays in the numerator. We have x to the positive 7th power. Now, let's look at the y's. We have y to the 0 power. Well, y to the 0 power is just 1. We don't really need that there. It's there to trick us. So we have y to the negative 1 power. Well, we can't have a negative exponent. It needs to be positive. Bring it to the denominator, make it a positive exponent, and it's to a 1 power, y to the 1 power, but we leave it there without writing the 1. Same thing with the z. They're trying to trick us here. Z to the 0 power is just 1. Leave it as such. Same operation happens. Z to the negative 1 exponent. Don't want that in the numerator. Put it in the denominator. Z to the positive 1 power. Again, don't write that power to be 1. Just leave it as such. And we have our final answer here. 3x to the 7th power over yz. And that's it. If this video was helpful for you, please subscribe to our channel and like this video. This helps us make more free math lessons for you and for students all over the world. So, as always, thanks for watching.
Minute math. When you need help, you use minute math. Minute math. When you need help, you use minute math. MinuteMathTutor.com.